Well, hello again. I hope that you are watching this on your phone or on your computer while you look along the iPad, because you can open up your iPad and work on this while you watch the video on your computer or on your phone. It's the best way to do it, okay? Because you have to submit this classwork and I'm doing it now with you, so it's easier if you just have two devices going. Unless, of course, you printed it on paper, and you can do that as well. All right, so let's get started. Okay, so today we're going to be working on being able to find the sine, the cosine, and the tangent given a coordinate, and see how it goes on a plane, how it all works out on a coordinate plane. So let's just do a warm-up. So find the smallest positive coterminal angle and name the quadrant in which it lies. Right? You should be looking at this on your iPad. So this is not something that should be that you should be waiting to only see on the video. Okay, so draw the original angle. Okay, so here it is. It's 440. So let's just draw that just to get it out of the way. So that drawing that would be like, well, that's 360, right? Remember 90, 180, 270, that's 360. And 440 probably goes a little bit more. I can be really sure if I go, well, 440, too big, right? Too big. So since it's too big, we minus 360. Minus 360, you get 80. So that makes sense. So that's there. So that is 440, which is the same. So 440 degrees is the same as 80 degrees. And that's called the coterminal angle. Okay? So now I have negative 30. That's too small, right? Too small. So when it's too small, I add full circle, which is 360. I add 360 because that's full circle. And that gives me 330, right? So in other words, negative 30 degrees is equal to 330 degrees. That's the coterminal angle. And notice that this coterminal angle is is the smallest positive angle that you can get. Negative 30 is not positive, so we needed to add 360. Okay, I'll go back and do the quadrants in a second. Right now I just want to do this. Okay, so now this one, again, too small because it's negative, right? So I'm going to say plus 360, and that gives me positive 90 degrees, right? So negative 270 is equal to 90 degrees. Oops. Is equal to 90 degrees, and that's the coterminal angle. That's positive, and that's that. Okay, and then this one, too big, so I'm going to do minus 360, and then I will get 220 degrees. So this one is 220 degrees is my coterminal angle. And to go back and talk about the quadrants, you should remember that the quadrants go like this. Here, I'll put it right up here. 1, 2, 3, 4. So 220. I'm also gonna draw all of these. So let me use a different color for this. All right, so I did this one, and I said this is I'm gonna say this is quadrant 1. I'm gonna do this one, 330, which is the same as negative 30. That's the original angle. That's quadrant 4. And this one is negative 270. Oops, got stuck. And that's quadrant 2. There it is. And then this one is 580. So that goes all the way around 360. And it keeps going to about there. And anyway, that's quadrant 3. All right, so that was a little warm up. Hopefully that was just you checking your work, and we can move on. Another thing you want to make sure you can do is the basic triangle using SOHCAHTOA. Cannot tell you enough how much you need to know SOHCAHTOA. So sorry if you're like, I'm really hoping SOHCAHTOA will go away. Think again, my dear and gentlemen and ladies. You need to make sure you know your SOHCAHTOA. All right, so let's remind ourselves. So I'm going to do the sine of S. Now, if I try to do the sine of S, that would be, if I follow my SOHCAHTOA, right? that would be opposite over hypotenuse. So here's S right here. So opposite is 1. And then you don't just go blank. You have to get that value. You don't just randomly just be like, well, since there's nothing there, I get nothing. No, you actually have to work that out. So you have to do some Pythagorean theorem. So you're going to go 1 squared plus radical 3 squared equals the hypotenuse squared. This is just 1. Radical 3 squared, well, that's just 3. Positive 3 equals h squared. So this is 4 is equal to h squared, so 2 is equal to h. So that's 2. Now we can finish this. We can go back here and be like, oh, by the way, sine of s is going to be 1 over 2. And sine of t is going to be, well, that's t's side. This is angle t, so here's t. So it's going to be rad 3 over 2. And cosine of s, go back to s. Adjacent over hypotenuse. And these are the same because they add to 90. And cosine of t, adjacent over hypotenuse. And measure of angle S. How do I get the measure of angle S to the nearest degree? So for that, I'm just going to figure out that the sine, I can use any one of those. So I'll say sine of S, because I want S, is equal to 1/2. So S, angle S, that thing, is the sine inverse of 1/2, which if you remember how to put that in your calculator, okay, you would just go sine inverse, clear. So, oops, sorry, clear. So second sine of 1 divided by 2 is 30 degrees. Okay, so that's 30 degrees. And now for this one, well, if I know one angle is 30 degrees, and I know this is my triangles over here, I'm going to go back to it. So I know that S is 30 degrees. This one must be 60 because they all add up to 180. 90 plus 30 plus 60. So this must be 60 degrees. Okay, so that one is 60 degrees. Okay, so let's move on. Now let's get into the nitty gritty here. All right, so we're talking about the cosine. This is like a formula of a fundamental concept. So a cosine of theta is x over r. The sine of theta is y over r, where r is the radius. I didn't really mention that, I should. And tan of theta is sine over cos, or y over x. And just say r is the radius. But all of this, and also one more thing, yeah, the cosine of the coordinate of x, y, some coordinate, is always just going to be r cosine theta, r sine theta. Okay, I used to remember this order by CS. I just remembered CS, and I would remember that order because we use it a lot. I used to think of this game Counter-Strike that came from a student. Never forgot it. That's what I always did. Anyway, back to this. Okay, so now I am given a coordinate. Wait this a second. I'm given a coordinate, and I would like you to find the sine, the cos, and the tan based on that coordinate. And so there's a lot of concept here that I want to go over. Okay, so if you make a sketch of this coordinate, so this is 1, 2, 3, 1, 2, 3, 4. So this coordinate is right there. I'll call it P. Right? So this here, and the reason I draw this down, I know it's just the coordinate P, but whenever you draw a triangle inside the coordinate plane, because we're going to be doing that coordinate P, the easiest way to write this using trig is you have to make a right triangle. And when you make the right triangle, listen to me now. One of the sides, I'll make a note of it. The side of the right triangle must be on the x-axis. It cannot be anywhere else. It must be on the x-axis. So here it is on the x-axis coming down. It's not on the y-axis, only on the x-axis. Not ever touching the y-axis, ever. Okay, so here you have it. Here's your right triangle. This bottom here is 3. This here is 4. Find out what the hypotenuse is. 3 squared plus 4 squared equals h squared. You're going to find that that's 25 equals h squared, so h is 5. Okay, so I can go here and call that 5. Awesome. So now I can answer the question. My question is, what is the sine of theta? Well, here's theta. It went up this way. There's my angle. My angle is always in the corner with the x-axis. So the sine of theta is opposite over hypotenuse, 4 over 5. The cosine of theta is adjacent over hypotenuse, 3 over 5. And the tan of theta is opposite over adjacent, 4 over 3. That's all you have to do. Now, notice that this works because this is what these formulas were saying. It's the x-coordinate, like cosine is the x-coordinate of the radius. This is the radius. If this, now you're like, wait, what radius? Where is this even, how is that even a radius? Well, the reason we call it a radius is we can picture, and you don't have to do this, but this is where it's coming from, that if you have this length r, that is the radius of a circle that can be going around, all the way around. So that's the radius. No matter what, the hypotenuse is always the radius. So I'm going to make a little note here. Hypotenuse is equal to the radius. It's very important, okay? So in any case, this is 4 over 5 is because it is the x. This is your x. Oh, I'm sorry. This is your y, and it's y over. The sine is y over. Let me show you. Is y over the radius. This all seems very complicated the first time. It's like a lot to, deal with. But you do it over and over again, it actually becomes super easy. So really, the problem is we can't get questions answered, okay? So I'm just going to go through it, and then when I see you guys in a video chat or, in a video chat, that's when we will try and clarify, okay? So just stay with it, try it again. Things take a few times to get used to it. I'm going to try the next one. Okay. I'm going to draw this. That's -5. So this is -5. And it goes up to 12. So there's my point. And since that's my point, I draw it coming down to the origin. And I have to make a right triangle, but it has to be one of the sides on the x-axis. So here I have it. There we go. So now all I got to do is I figure this is -5, right? And this here is 12, right? And now I just need to find out what the sine of theta is, which is, here's my theta. I know theta is this whole thing, but you just treat it as this little angle in here. So just remember, sine of theta, it's the y coordinate over the radius. So the y coordinate is 12 over the radius, which is like the hypotenuse. If this was a big triangle, it's really just finding the hypotenuse. So it's 12 over the hypotenuse. So it's, because this is, think of it this, CS. So it's 12 over, I need to get that hypotenuse. So let me take a moment and go -5 squared plus 12 squared equals hypotenuse squared. So this is going to be 169. It's hypotenuse squared, so h is equal to 13. So this will be 13. So it's going to be 12 over 13. Sine of theta is 12 over 13. Cosine theta. Now remember, cosine theta is the x coordinate over the radius. So it is the x coordinate, which is -5, over the radius. And the radius is 13. And tan of theta, that's always a little tricky. It's sine over cosine, or basically just y over x. So tan of theta is just y over x. So it's just y is 12. That's -5. So then it's just 12 over -5. Okay? You're going to get the hang of it, I promise. Let's try one more. Okay, so for this one, this is -3, 1, 2, 3, -2. So that's right here. So I make my triangle. I make it with the right angle. This is -3. This is -2. Okay, if you use positive values to label these, it's really not a big deal. It all works itself out, but you do have to pay attention to the signs when you write sine, cos, and tan. So that does matter. So remember, we're going to still need the hypotenuse. So that's going to be -3 squared. So -3 squared plus -2 squared equals hypotenuse squared. So that's 9 plus 4 equals hypotenuse squared. So then that's 13 equals, so h is equal to square root 13. So now let's go back here and we go sine theta. Well, sine, just remember, it is the y value over the radius, or rather the hypotenuse. So it's the y value. There's xy, so I call it CS, xy, any way you want to look at it. So it's y value, or s, -2 over, what's the hypotenuse? Rad 13. So this is cosine theta is -3 over rad 13. And tan theta is y over x, or sine over cosine. So I think of it as sine over cosine because these cancel out. -2 over -3 is +2 over 3 because the negatives cancel. So that one's done. These two have a radical in the denominator, which we like to not leave like that. So if you rationalize, you multiply top and bottom by radical 13, right? So I'm just going to make this neater because I ran out of room, and you will see. So I'm going to write this as -2 over 13, -3 over rad 13. So if I multiply top and bottom by rad 13, I will get this one to be sine theta is equal to -2 rad 13 over 13. Cosine theta is equal to -3 rad 13 over 13. And of course, just to make it complete, tan theta is 2 over 3. And there we go. That's them. I'll just leave it there for a second. Hopefully it's all clear. And let's get to the next side. So over here, now they want you to try. So at this moment, you should pause the video and try and set it up yourself. Draw the triangle, get the hypotenuse, or quote unquote the radius, it's the same thing, and find the sine theta, the cosine theta, and the tan theta. Okay, hopefully you paused it and did it already. What did I do that for? Yikes. I don't know. I got a little distracted, so sorry. There we go. Okay, so the coordinate is 8, 15. So it's 8 and then up to 15. So it's right up here. So I make my triangle. And this is the same as 15 here. And I get my hypotenuse. So 8 squared plus 15 squared equals h squared. So, you know, you can type that whole thing in just to show you how easy that is to do. You can just type in 8 squared plus 15 squared equals 289. So then h is equal to, I believe, 17. Square root of 289. It is 17. So I go, okay, now I know my radius, hypotenuse, is 17. So my sine of theta, remember what I told you, CS, x, y, any way you want to look at it. So sine of theta, I go CS. So at S, it's 15 over the hypotenuse. Cosine theta is C, 8 over hypotenuse. Tan theta is going to be sine over cosine. So this over that, which the 17's cancel out, and you get 15 over 8. There we have it. All right, now we go. Next one, make sure you can do it. Again, so you have 1, and you go, what? Square root negative root of 3? Don't sweat it. Just know what quadrant it is. So here's, I'm not gonna make 1 tiny because it's just gonna make it look so small. So I'll make 1 go all the way over here. And I'll make rad 3. It's really not a big deal right here. Right? So here's my point. Remember, the y value, the x-axis has to be a side of that triangle. Right? So this is 1, and this is negative rad 3. And my theta is you go all the way around, right? But we look at this angle to do it. So sine theta, so I go back to my quadrant, CS. So sine theta is my S. So it's negative rad 3 over, I forgot to get the hypotenuse. Well, let me go back and do that. 1 squared plus negative rad 3 squared equals the hypotenuse squared. Now, if you type this in your calculator, some people type it in wrong, so don't be that person. So you're going to write in, some people go 1 squared, and then they go plus, and they go negative. I'll do it wrong so I can show you. So negative rad 3, and then they go squared. And the reason that that's wrong is that you need to put the negative rad 3 in parentheses because it's only squaring the rad 3. So you have to go back and put in the parentheses on the whole negative rad 3. So, insert negative. Okay, that way it looks like that. Okay, enter. That's 4. You could have done that in your head. I just wanted to show you how that works. Okay, so then that's going to be 4 equals h squared. So h is equal to 2. So this is over 2. Easy enough. Now that I know that that's the hypotenuse, it's easy. Cosine theta is 1 over, and it's positive, 1 over 2. And then tan theta, I just do sine over cos, and since those 2's cancel, it's just negative rad 3 over 1. Or just really negative rad 3. That way it looks nicer. Okay, so there you have those, okay? Now, we're going to look at the idea of the unit circle where the radius is 1, okay? When I say the radius is 1. So I was telling you before that there's a whole circle going around here and that there's little triangles that are formed around it, right? And this whole concept of trig all kind of comes together Right now we only give it to you in pieces and then it all comes together. But yeah, so now we're going to look at this when the radius is 1 or the hypotenuse is 1 in this case. So they said, you know, if the coordinate was xy, determine the sine, the theta, and the tan theta. Yours might be organized a little better than mine right now, but I'm not sure if I remember how I did that. So I'm going to call this x, y, because they called it xy in here, right? And then, so let's see, sine theta. Well, this is so easy. Isn't it just CS, like I told you, CS? So you go, well, it's just x over the hypotenuse 1. So it's just x. I mean, do I really have to write x over 1? I mean, we're good. Cosine theta is equal to, well, I have this backwards. Sorry. This is y. And cosine theta is going to be the x value. Sorry, x over 1, right? And then tan theta is just sine over cosine. So that's just going to be sine over cosine is y over x. All right, so there we have it. All right, so sorry, somebody's calling me, but I think they just stopped. Okay, so there we have that. So that's y, x. Okay, so now we're doing okay. So now let's talk about, well, that actually is important because this is what we call a unit circle. And whenever they give you the unit circle, you could just say like whatever CS, that's the cos, whatever they ask you for sine, that's just that y value right there. So let's look at here. Here's an example. Like, let's say they gave you this, you really can't see the p, but the p's right here. Okay, it's a little small. Maybe you can see it better on your iPad. But anyway, so if you look at this and they gave you this coordinate, they're telling you that this coordinate is 8 over 17, comma, negative 15 over 17. Okay, so now they're asking you to find the sine, the cos, and the tangent, right? They ask you find the sine, cos, and tangent. So the sine of theta, and notice theta is all the way around this way. Sine of theta is, well, since this is a unit circle, and it is, you can't see the quadrants too well, but this is 1, this is negative 1, right? So the sine of theta is just, if you go on top of the it's so easy. You just go right on the coordinate, you put C, you put S, and since you know that the radius or the hypotenuse is 1, right? We're happy campers when it's 1, then all you have to do is say the sine of theta is just negative 15 over 17. Done. That's it. Cosine theta, C, 8 over 17. Done. Tan theta, sine over cosine. Tan is always sine over cosine. Done. Super easy, okay? So get this. Now, you try some more. So again, these are all on a unit circle. They will tell you normally that's a unit circle, but in case you're not sure, how could I make sure? Like, you can graph it if you want, or you can just realize that all I need to do is square each one of these. Like if I just do negative 0.8 squared plus 0.6 squared, guess what it's going to equal? The hypotenuse squared. Guess what this is? 1. So this is, the radius is 1. This one, you do the same exact thing, the radius will be 1. The radius will be 1, so we'll make it easy. Well, let's just do it. So, so this would be, it says determine sine, cosine, tan, and draw the angle. All right, let's just find out what each one is. Sine of P is equal to CS, 0.6 over 1. Cosine of P, negative 0.808 over 1. Tan of P is sine over cosine. So it's 0.6 over negative 0.8, right? And if you want to calculate that, you will get 0 0.6 divided by negative 0.8. So math frac. Oh, that's negative 3 over 4. Okay, there you go. And you draw that. That looks like negative, positive. Yeah, it's around here. There you go. That's all you need to do. Let's do another one. Okay. So you don't have to draw it right away if you don't want to. Just find the sign. I mean, you can check. Let's check what the radius is. So if you check for the radius, so you do 3 rad 5 over 7 squared plus negative 2 over 7 squared. Put it in your calculator. It's going to be hypotenuse squared, and that's going to give you 1. The radius is 1, the hypotenuse is 1, any way you want to look at it, right? So the sine of P is CS, remember CS, so negative 2 over 7. Cosine of P, 3 rad 5 over 7. Tan of P, sine over cosine, so negative 2 over 3 rad 5. Don't like to leave that in the denominator, so I'm going to rewrite it neater. Multiply top and bottom by the rad 5 I don't want. Negative rad 25 over 3 times 5. Not going to happen often. All right? If you wrote this, I'd probably be really fine with it, but just make sure, you know, you can get like this most big part. The rest of it's extra, okay? So make sure you can rationalize, you know, once you get good at this. Okay, so now this one. Now you might be like, I mean, if you check for the hypotenuse, oh, I didn't draw this. Let me draw this first. Sorry. So if I draw this, this is positive, then negative. Don't worry about the number. It doesn't matter. It's just the fact that it's positive, then negative. So positive, then negative. Oh, here it is. Okay. There it is. Okay. So now this one's the weird one. I mean, you can try and do and say what the r squared is. Find out what the hypotenuse is. You can go negative 1 squared plus 0 squared to get h squared. And you're going to find that this is 1 equals 1. So yeah, the radius is 1. So this is fine. So the sine of theta, the cosine of theta, the tan of theta. What's the sine of theta? Well, the sine of theta is going to be CS, 0. What's the cosine of theta? See, negative 1. What's the tan of theta? Tan of theta is sine over cos, so it's 0 over negative 1. Never ever leave it like that. Compute it. That's 0. If you have to, put in your calculator, but don't leave it like 0 over negative 1. Like, finish it, okay? Finish it off. So to plot this, that's negative, but that's not like positive or negative. That's right here. Oh, that's 180 degrees. Every time we were doing this, theta was 180. If you go on your calculator and you type in, check this out. If you type in sine of 180, guess what I know it will be? I know it will be 0. And if I do cosine of 180, I know that's going to be negative 1. And if I go tan of 180, that's going to be 0. Now, I could have just had you put that in your calculator, but we're trying to get you to make a connection. Okay. Lastly, let's do our next part. So now that we're able to identify the quadrants, we need to be able to identify where the sine, cosine, and tangent are positive or negative. So I just want to clarify something about inequalities that get people really confused. When they say x is this symbol here, 0, people get confused on what that means. That means, when you see it, what does this mean? This means that x is negative, because that symbol, see how it makes like almost an L, the letter L? That's less than. And I know that's like, some of you guys are rolling your eyes like, yeah, I know, but a lot of people confuse that. So I really want to clarify that. Okay, so that means less than 0. So when they say x less than 0, that means x is negative. Okay, when they say x greater than 0, that's the greater than symbol. Greater than 0 means x is positive. Okay, so that's what that means. All right, so just keep in mind that this is less than and that's greater than. Okay, so now I just want you to figure out in the quadrants, like I just want you to do a plus sign and a minus sign, just to see, like if this quadrant, everything in here, since these are all positive numbers and these are all positive numbers, this would be a positive and a positive. See that? Over here, this x coordinate would be the x values are negative, and then this is up, the y values are positive, right? Because that's x and that's y, right? That's x, y, x, y. This is x and y, right? But in here, it's negative, and going down, it's negative. So those are both negative. And over here, it's positive for my x. So it's positive, but my y is negative. My y is negative, okay? So now, if I remind you that this is CS, 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 C is for cos, S is for sine. Notice where is both cosine, sine, and I know tan isn't here because it's like all cos and sine, like what the heck about tan? What would tan be? Tan would be tan theta. Here it's positive over positive is positive. Okay, so we're just going to make a note of that. Here, CS, and you can make a little note, tan of theta would be, well, since they're different signs, would be negative. And over here, tan theta would be, well, since it's negative over a negative, positive. And over here, positive. And then over here, tan theta, since it's a positive over a negative, that would be negative. Oh, I meant negative, whatever. You can just write the word positive too. That's fine too. Okay, so, excuse me. James! Oh, he can't hear me.